Okay, starting fresh, we're going to do the section on energy. Energy, some facts about energy. The standard unit of energy is the joule. It's named after James Joule. Energy is a scalar. Even though its components are vectors, when we get to the equations, energy is a scalar, which means it only has magnitude. It doesn't have a direction, which is really good because then we don't have to worry about trig or cosine so much as trying to figure everything out and breaking everything up into its components when we add different types of energy. Even though energy is a scalar, it can be mathematically positive or negative, but the positive or the negative you see does not mean its direction. That's actually the mathematical amount. We're also going to talk about conservation of energy. Conservation of energy, there's also conservation of momentum, and there's conservation of mass. Conservation of energy just means that energy cannot be created or destroyed, it can only change states. Conservation of mass says mass cannot be created or destroyed, it can only be changed into smaller parts. We're also going to find out that energy can be transferred into different types of energy. Thermal energy, nuclear energy, but usually parts of it are changed into somewhat less productive. Friction has the potential to change 100% of the mechanical energy into thermal energy. This is important when we start talking about your brakes. When something is in motion, it relies on kinetic energy. In order to make it stop moving, we have to get rid of all that energy. The way your brakes work is it turns that kinetic energy into thermal energy, which is heat, which is why your brakes get so hot, because it's transferring all that energy you had built on in you as you moved, and it's changing it into heat energy. Alright, so the many types of thermal, we talked about briefly thermal energy. We're going to talk about radiant energy, and we're going to mention nuclear energy. But that all comes pretty much later on. Our main focus for this chapter is mechanical energy. Especially for the AP classes, this is mechanics. This is the main thing we need to concentrate on. The main types of mechanical energies are work. Work is the foundation of everything. The formula for work is force dot product of the force vector and the displacement vector. When we do the dot product means we're taking the parallel components, which if we break down into a nice easier equation, work is equal to the magnitude of the force vector times the magnitude of the displacement vector times cosine theta. Theta is the angle that the force and the displacement vector make. That's your theta. Don't get it confused or make it think that it's related to the horizontal. No, you draw the two vectors and it's the angle that they make. Then we have the very, very complicated work equals the integral of force with respect to the position. This comes later for the AP Cal students, but doesn't really relate too much for the physics honors at the moment. The other types of energy we're talking about is potential energy. Potential energy is stored energy, meaning you can get it back. The main types of potential energy are gravity and elastic. The reason it's called potential energy is because you can get the energy back. Imagine if you stretch a rubber band, which is an elastic energy. You stretch it out, you get like 120 joules to stretch it out. Once you let go of the rubber band, all that energy is going to come back to you. The same thing with the spring. If you have a spring and you exert a force to stretch it out, when you let go of the string, it's going to come bouncing back in this direction with the same amount of work that it took to stretch it out. The same thing happens with gravity. If you lift a ball up with a certain force to a certain distance, you do work. When you let go of the ball starts to fall by a certain distance, and it starts to get all that work you put in back into it. So they're considered potential energies because they have the ability to store work. And we'll talk about those more in detail later. The next thing we're going to talk about is kinetic energy. Anytime something is moving, it has kinetic energy. Kinetic energy can only be positive. Potential energy can be positive or negative, because it's based on mass times gravity times height. Height can sometimes be positive or negative depending on its reference point. So potential energy has the potential to be positive or negative. The same thing with elastic energy. The elastic energy, H, is really more replaced as delta X, which is how far the spring moves from its relaxed position. Now, it can move out, making it positive, or it can move in when it bounces back, making it negative, so it can also be positive, negative. Kinetic energy can only be positive because the mass can't be positive. The velocity can be positive or negative, but the moment you square it, it becomes positive. So it's impossible for you to have negative kinetic energy, which goes back to what we talked about before. Every object in motion has kinetic energy, and it has a positive amount of energy. So in order for me to do or make that object stop, I have to do negative amounts of energy. And then we have this mechanical energy section right here, which just goes into the formula for mechanical energy, which is E. And the mechanical energy is the sum of all the kinetic energy and the sum of all the potential energy in a system. And then you can say that the change of mechanical energy is equal to the change of kinetic energy plus the change in potential energy. But we'll also relate it to another object called non-conservative work. And non-conservative work is equal to the change in potential energy. If there's no change in potential energy, meaning the kinetic energy and the potential energy, when added together, keep adding up to be the same thing, there is no non-conservative work being done. And that also comes way, way later.